This podcast is going to be about solutions, and these notes need to go on page 31 in your notebook, and I would like you to write these Cornell style. So make sure that you have a title of solutions at the top, the date in the top right corner of your page, and room for a summary at the bottom, and then on the left side you need a narrow column where you can write questions or vocabulary terms. And if you want to pause and do that now on page 31, set up your page, and then we'll get started. The first thing we need to do, of course, is define what a solution is. And a solution is a mixture of two or more substances that is all the same, uniform throughout. And that should sound like a definition of a homogeneous mixture, and it is, because a solution is a type of homogeneous mixture. They can be physically separated, just like any mixture can. And the thing about solutions is that there are terms for the parts of a solution, the things that have been mixed into the solution. We have special terms for those. The first is the solute. It's a very important vocabulary term. The solute is the substance in the smallest amount, and it's the one that dissolves in the solvent. So you're going to put something into something else to mix it. The one you're putting in is the solute. The solvent is the substance in the mixture that's doing the dissolving. It's in the larger amount usually, and it does the dissolving. So for instance, if we were making iced tea with iced tea, the powdered iced tea mix, you would have water as your solvent, and into that you would put the iced tea mix, which is your solute, and then when you mix it together, you get an iced tea solution. Another example is salt water, and salt water is a mixture of water with a whole bunch of salty stuff, and the salty stuff is going to be your solute in that case, and the water is your solvent. So let's say you look at the ingredients on a can of Coke, and it lists the ingredients as carbonated water, high fructose corn syrup, caramel coloring, etc. In the case of Coke, what is your solvent, and what are the solutes that you find in Coke? Well, the thing that's listed in the greatest amount is going to be your solvent, and in that case it's going to be the carbonated water. The solutes, there are lots of them. The main solute is going to be corn syrup, but all of these other things that are listed, possibly sucrose, caramel color, phosphoric acid, and the rest, are also solutes in Coke. One thing that I think is important for you to know is that water is the universal solvent. It's called the universal solvent, and it's called that because it is most often, in our world, it is most often a solvent. It dissolves almost everything, and so when you think about the ocean, it's the solvent. You think about lakes and rivers and ponds and your body, all of the things that are dissolved in there, water is going to be the solvent in many cases. Now, when we're talking about solutions, we can talk about concentration of solutions, and you're probably familiar with this. A concentration of a solution is the amount of solute that is dissolved in the solvent at a given temperature. If a solution is dilute, it has a little bit of solute for a lot of solvent. So think about just putting a teeny bit of iced tea powder or a teeny bit of Kool-Aid in a big bunch of water. It's not going to have much flavoring. It's not going to taste like much. We call that dilute. If it has a lot of solute for the amount of solvent, then we call it concentrated. And if it has very, very high concentration of solute, in other words, lots of solute for the solvent, so much so that you can't put any more in and have it dissolve, we call that saturated. It's a saturated solution. And if it gets to the point where it has so much, you heat it up and you get lots of it to dissolve. Sometimes it can become super saturated, and I have a demonstration for you next week with a super saturated solution if I can get it to work. Now, so far we've been talking about solutions, which are a type of homogeneous mixture. Now I want to tell you about a couple of different types of heterogeneous mixtures that have a special name, just so that you know what you've heard of these. The first is a suspension. This is a heterogeneous mixture in which the particles in the solvent are so large they settle out unless the mixture is constantly stirred. In other words, if you don't stir it, all the particles fall to the bottom. An example of this is salad dressing. So you're probably familiar with these Italian salad dressings and maybe a vinaigrette salad dressing where all the particles separate out. You have the oil at the top and then you have all the good yummy stuff down at the bottom, and how things settle out, and you have to shake it up. Anything you have to shake up because it's going to settle out, that's considered a suspension. You can also think about things like if you have sand in some water, how the sand will always drop to the bottom, but you could stir it up and it could mix around, but then when you stop stirring, the sand all drops to the bottom again. That's considered a suspension. The second type of heterogeneous mixture that I wanted to talk to you about that has a special name is a colloid. It's a kind of a funny word. But colloids are mixtures in which the particles are somewhere between a heterogeneous mixture where they're big and chunky and floating around and a homogeneous mixture where they're microscopic and you don't see them at all, so it looks like one thing. In a colloid, the particles are really, really tiny, like fine dust particles, and they don't settle out and you can't really see them, but what they do is they scatter light. And so makes things look foggy. And if you actually shine light through a colloid, you can see the beam of light. So you see here shining a light through these liquids, you can actually see the beam of light. This is what makes your headlights shine in the fog, because fog is a colloid. Another example of a colloid is milk and Jell-O. They are considered homogeneous, but they're a special kind of mixture in that the particles are a little bit larger and, like I said, they scatter light. The other thing I wanted to talk to you about with this particular lesson is some substances in solution can become either acids or they could become bases. And we've talked about acids and bases before and about pH and the pH scale. So I'm just going to go through this a little bit quickly. But this happens while substances are in solution. First, I want to tell you a little bit about acids. Acids have a pH less than 7. Remember, 7 is neutral. They have a tendency to taste sour, so think of all those things that you eat that taste sour, like lemons and limes and most fruits, actually. And they also react with metal. They actually corrode metal, so they'll eat away at metal. And those are the properties that acids have. So in solution, these particular substances, lemon, the acid in lemon is in water because there's, water in the lemon. So it's always a solution. But in citrus fruits, it's citric acid. In vinegar is an acid, it's acetic acid. In grapes, it's tartaric acid. And in apples and pears, it's malic acid. But these are all dissolved in the liquids. Those are the properties of acids. Then we have bases. Bases have a pH greater than 7, up to 14. They have a tendency to feel slippery, so think about soap. Soap is a base. So anything you can think of that sort of feels slippery. They taste they taste bitter, although they are generally not things you want to be tasting. But bases tend to taste bitter. If you've ever gotten shampoo or soap in your mouth on accident when you were showering, you know what it kind of tastes like. It has that bitter taste to it. They tend to be things like cleaning products. One of the things that I want to make sure you understand is that strong bases like bleach or drain cleaners or ammonia are just as potentially harmful as strong acids. You think about hydrochloric acid or sulfuric acid that are so potentially harmful to you. Strong bases are just as harmful. Okay, so as a final and reviewing kind of conclusion here, we talked about solutions and how solutions are a type of homogeneous mixture in which you have a solvent which dissolves a solute. A solvent is present in the greater amount, so you dissolve the solute in the solvent. We also talked about suspensions, which are a type of heterogeneous mixture in which all the particles tend to fall to the bottom like salad dressing. We also talked about colloids, which are somewhere between suspensions and solutions because the particles are very, very tiny and they tend to float around, but they scatter light. We also talked about acids and bases and their properties and how acids and bases form and show their properties in solutions. This is all I have for the notes for this time. And Indy, my puppy dog, says goodbye.
Made with Doodlecast Pro.